I don't know what camera we used. I think it was an off-the-shelf like Nikon we picked up off eBay. If you're young and doing a startup, eBay's great. But yeah, no fancy camera there. That's really just the light illumination, and we have.
You can just capture with the normal.
Well, we have a microscope objective underneath, and
Yeah.
so we're watching the light come through, but it's hooked up to a normal video, just a normal like DSLR-based camera.
Is there now, before we keep going, is there another company that thinks about?
Sure, yeah. I mean, let's see. You like the one where we're printing the cell encapsulation device?
Yeah, that was in the other email?
Yeah, I think that was in the other email. Yeah. So again,
this is cool. The
yeah.
cell encapsulation device. Okay.
Well, yeah. So we can use this to encapsulate 2,000 to 3,000 cells. It may be useful in diseases where you want encapsulated cells, such as diabetes. You can protect them from the immune system, or just make them better for transplant. And so that's one without cells present, but we routinely print these around human insulin-producing cells, and we're testing those in the lab right now. As we speak, we have an active project with that. And so the cells are alive, they maintain insulin production, and we're looking at bringing that into animal studies really soon.
And this is real time.
That's right, yeah. So that's real time. So that's as fast. So you want to give that another go?
And you're printing. Yeah. You're printing. This can fit 2,000 cells.
2,000 to 3,000 cells will fit in that structure, and
that's
about 200 microns across and about 250 tall.
And 250 tall, and then you put 2,000 cells in there, and then that encapsulates those cells. And then it enables you to run tests within those environments for, you said, for diabetes.
Exactly.
Was one.
Yeah.
And then what's the difference between doing it here versus doing it like in vitro or something? Like why here?
Oh, why would we do it in this?
Yeah. This environment.
So this environment, it's easy for us to do things like grow stem cells in the lab. We have a collaboration where they grow iPS, pluripotent stem cells, give them all the signals to become insulin-producing cells, and then they can send them to us, and we can encapsulate them. And so we have an active project doing that. And so in an in vitro environment, it's easier to just control what cell types you're getting, do all the tests to make sure that you're transplanting what you believe you are transplanting. And so the lab environment can be controlled in a way that makes everything safer. I'm not sure if I answered your question.
Okay. Well,
kind of. Yeah, sure.
This is brand new. When was the last time somebody was like, oh, I can